Hello everyone, in this video we're going to explore advanced limits of composite functions. Alright, before we're going to dive into the question, let's review the theorem behind this topic. If the function f of s is continuous at s equals L and the limit of the function g of s when s approaches a equals L, then we can conclude that the limit of the function f of g of s when s approaches a equals f of limit of the function g of s when s approaches a. If the function f of s is not continuous at s equals L, or the limit of the function g of s when s approaches L does not exist, then we cannot apply this theorem. So keep that in mind. Now we're going to go to the example number 1. This is 2016 BC International Exam question 88. Given the graph of the function f of s at right, we need to find the limit of f of 1 minus s squared when s approaches 0. So the inner function right here actually g of s, right? So we need to find the limit of 1 minus s squared when s approaches 0. Substitute 0 for s over here is actually 1, right? Now we look at the graph right here. The function f is discontinuous at s equals 1, right? So we need to say the limit does not exist because f is not continuous at 1, right? So the theorem cannot be used. So we need to use different way to find the limit of this composite function, right? Now I'm gonna let u be limit of s squared when s approaches 0, right? So it's actually 0, right? Now I'm gonna let v equals limit of 1 minus u when u approaches 0, right? U equals 0 right here. When 1 subtract anything, it's always less than 1, right? So to be 1 minus, right? So then you can conclude that limit of, now we have the function f right here, and the whole thing right here actually v right here, right? F of v when v approaches 1 minus right here, right? So I can replace the function f of v with f of s, right? So I have limit of the function f of s, and then this guy s approaches 1 minus, right? So I'm going to use the graph right here, right? So 1 minus, which means 1 from the left, right? So this guy right here, the answer must be 3. Now let's move on to example number 2. We need to find the limit of f of s when s approaches 0, right? So first we need to find the limit of the inner function, right? F of s when s approaches 0. We're going to use the graph here, it's actually 2, right? Now look at the function f of s right here. It's actually discontinuous at s equals 2, right? So the theorem cannot be used, right? So I'm going to let u be the limit of the inner function right here, f of s, when s approaches 0 plus and minus. Look, when s approaches 0 from the left or 0 from the right, the limit of the function approaches 2 minus. Look at this one. It's from here all the way down. This guy go down, right? It's never above 2, right? So this guy actually 2 minus, right? So then you can conclude that the limit of f of this guy actually u, right? F of u, and then when u approaches 2 minus, now I'm going to replace f of u with f of s, right? So I can use the graph right here, right? Now the limit of f of s when s approaches 2 minus, which means 2 from the left, right? The answer must be 0 over here. Now let's move on to example number 3. We need to find the limit of the function f of s when s approaches 0, right? Now we need to find limit of the function f of s, which is the inner function first, when s approaches 0 plus it's gonna be 2 right here, right? Now limit of the function f of s when s approaches 0 minus is actually 2, right? But observe that the function f is discontinuous at s equals 2, right? So it tells us that the limit of f of s when s approaches 0 does not exist. Now let's move on to example number 4. Alright, the theorem cannot be used since the limit of the function f of s, which is the inner one right here, when s approaches 0 plus and minus, right? 0 plus is going to be right here, 0 minus is going to be right here, equals positive and negative infinity, right? So it tells us that the limit of the function f of s when s approaches 0 does not exist, right? So the theorem cannot be used. Now, this guy actually the inverse function, right? The function is its own inverse, right? So we have f of s actually 1 over s, right? So to be s. So the limit of f of s when s approaches 0, actually the limit of s when s approaches 0, and it's going to be 0, right? And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.